once again, how do you know when to use the delta T equation versus using the Q equals MHF, Q equals MHV equations, right? Now, funny enough, you can use the concept of the heating and cooling curves to do that. Now, once again, bam, okay? This is a heating curve up there, right? Now, we agreed at the flat lines, at the horizontal lines, our temperature is not changing, okay? So anywhere you have a temperature change, okay, temperature going up or down, use the delta T equation. But anywhere where you have fusion or freezing, you have to use the H of F equation. Anywhere you have vaporization or boiling or condensation, you gotta use the H of V equation. You can't forget that, folks. Very, very important. I keep saying you can't mix and match. All right, so we got a problem here, right, guys? And it simply says, how much energy does it take to condense 700 grams of steam at 100 degrees C? Now, what happens sometimes, students see 700 grams, they see 100 degrees, and they're looking for heat. They feel they have to pile everything into the equation and just solve it, right? And not even look at the equation on the reference table, but just use all these guys right here. So my analogy is this. If someone says to you, okay, make a cake, and they give you butter, they give you flour, they give you broken glass, and they give you eggs, right? And they say, okay, make your cake, right? What do you use? You use everything? Okay, no, from experience and from recipes, right? You're gonna leave the glass out, okay? Use the butter, the flour, and the eggs, right? Same principle. The equation, okay, is here, and you're looking at it, right? You look over here. The key word here is condense, right? So that's the clue as to which equation you're gonna use, okay? Because we know we have Q equals MHV, we know we have Q equals MHF. But since condensation, right, takes place at the same line where vaporization takes place, okay, we're gonna use that H of V equation, okay? So Q is equal to M times H of V, right? And we're looking for how much what? How much energy? We should be experts by now. What letter is energy? Energy is represented by Q in the equation. So we're looking for Q. So Q is going to be equal to M times H of V. All we have to do now is plug the values in. Now, the mass is given to you as 700 grams, right? Okay? And you're going to times up by the H of V of the substance, and it's steam, right? We know steam simply is water in the gas phase, yes? Okay, so you look on your reference tables, okay? The front of your reference table on table B, the heat of vaporization is 2260. Now, after a while, you probably memorize that after a while, right? So it's 2260 joules over grams, okay? Now, guys, I keep saying over and over and over, use units, use units, use units, right? So the grams and the grams cancel, bam, 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 they're gone. You're left with joules. You're looking for heat energy, okay? That makes sense, okay? And let me see, from my calculation, right? I got a huge number, guys. I got 1,582,000, okay? Bam, all right, joules, okay? Now, let's say they asked you how many kilojoules is that, as we said before, right? You start here at the end, and you move decimal 3 places to the left, and that will be kilojoules, okay? But that's your answer. You're good to go. Let's do another one. Okay, over here, trying to get a good view of it. This question right here. Alrighty, we have if a metal, right, has a mass of 355 grams. You stop right there. They gave you the mass. That's M, right? As before, we've done before, no problem. And it takes 250 joules. Now, what joules represents? What letter? Q, right? Good. So they gave us Q. So they gave us heat energy, and they gave us the mass. Okay. So you continue reading now. To melt. Now, anytime, folks, you see a phase change in a calculation problem, you underline that phase change. You ask yourself, where does it fall on the heating curve? Does it fall on the fusion and freezing horizontal line, or does it fall on the boiling and the condensation horizontal line? So we know from experience, right? Melting, the other name for it is fusion, right? So automatically we're thinking we're going to use the heat of fusion equation, right? So it's looking for, okay, what is the heat of fusion of the metal? Okay, so they're looking, they gave it away. They're asking you to find H of F. So, You got your triangle, bam, okay. Q is equal to M times H of F. We're looking for H of F, so put a circle around it. You put your fingers over it. The rest of the equation is Q what? Q over M. So H of F is equal to Q divided by the mass. Heat divided by the mass, that's going to give you H of M. So you choose your guys from your equation, right? You see 250 joules there, 250 joules goes there over the mass, which is 355 grams. You go 355 grams. Now, funny enough, right? These guys do not cancel, and you want that because the funny thing is, heat of fusion and heat of vaporization, they're in units of joules per gram. Okay, so you know you're on the right track. Alrighty? And from my calculations, I got 0.704 joules per gram. And I always said I'm not using slick figs, so if you got around that ballpark, you're good to go. Okay.